Welcome back to The Explainer. Now, as a scientific analyst, I'm usually breaking down a dense research paper, some massive new data set, or maybe a historical event. But today, we're looking at something totally different. And honestly, it's incredibly fascinating. We are analyzing a very specific framework. It's literally a blueprint designed for delivering a presentation on arguably the most complex topic of our time, the combination of quantum computing and artificial intelligence. What we have here in our source material is basically the foundational DNA. It's the exact set of instructions on how you actually explain the unexplainable to the masses. It's a total masterclass in structured communication, and we're going to deconstruct exactly how it works.
So, the source document we're looking at acts as this very precise, unyielding set of instructions, and right out of the gate, it makes a really clear demand. The delivery style absolutely must be visually engaging and fast-paced. I mean, think about it. When you're tackling the intersection of quantum mechanics, which, let's face it, is notoriously counterintuitive, and artificial intelligence, which is advancing at just breakneck speed, you literally cannot afford to drag your feet. The framework recognizes that to keep anyone's attention on such a dense technological crossover, the information just has to move. It's got to pop visually. It's not just about what you say, it's really about the momentum of the presentation itself.
So, the crucial point is our visual roadmap. The framework demands a strict four-step progression. First, the revolutionary hook. Second, relatable analogies. Third, real-world breakthroughs. And finally, a forward-looking statement.
Okay, let's dive right into this. Step 1, the hook, establishing a revolutionary concept.
The whole strategy here is to justify, literally from second one, why merging these two fields is a revolutionary leap for humanity. You can't just ease into a topic like this. You definitely can't start with some dry history lesson on computers. You have to grab the audience by the lapels and tell them, hey, the world is about to change and here's exactly why. It's all about immediately establishing the massive world-altering stakes involved in this technology.
Moving on to Step 2, simplify. Breaking down complex quantum concepts.
Now, what's really interesting here is the intense communication challenge this sets up. The source clearly defines the target, a general audience. But then it slaps down a massive constraint. They possess absolutely no physics background whatsoever. I mean, think about how difficult that is. You're being asked to explain subatomic computational states, stuff like superposition, entanglement, qubits, to someone who probably hasn't taken a physics class since high school, if they even took one at all. The blueprint fully acknowledges this tension. It forces the presenter to just completely strip away all that academic jargon that normally surrounds the topic.
So how in the world do we bridge that massive knowledge gap? Well, the source is completely explicit about the method here. Simple, relatable analogies. That is the required tool. You absolutely can't use complex mathematical formulas. You have to compare a quantum computer to something the audience already understands in their day-to-day, like a labyrinth, or maybe a spinning coin, or a vast library. The whole framework relies entirely on translating the abstract math of quantum mechanics into everyday, tangible concepts. Honestly, it's the only way a layperson can really grasp the sheer processing power we're talking about here.
All right, Step 3, breakthroughs, providing real-world proof.
Here, you must ground the presentation in specific, real-world breakthroughs. You can't just float around in the realm of theory or talk about what might happen someday. You have to anchor the audience's understanding by pointing to actual, concrete milestones that have already been achieved. This step is absolutely crucial because it validates that revolutionary hook we established right at the beginning. It basically says to the viewer, hey, remember when I told you this was revolutionary? Well, here are the receipts. Here's the concrete proof that it's already happening.
And finally, Step 4, the future, looking ahead to the next decade.
To wrap up the narrative arc, the final requirement is super simple but incredibly effective. End with a forward-looking statement. After breaking down all the complex realities of where we are right now, the framework wants the presenter to lift the audience's gaze up to the horizon. It's a classic, incredibly powerful rhetorical device. You don't end on a period, you end on an ellipsis. You want to leave the audience feeling inspired, maybe a little bit awestruck, and just deeply curious about what comes next.
Because when you combine artificial intelligence that can actually learn and adapt with quantum computers that can process variables at speeds we can barely comprehend, what could this technology actually enable in the next decade? Are we going to redesign our materials? Will we cure diseases right down at the molecular level? Or maybe unlock secrets of the universe we haven't even thought to ask about yet? That is the provocative question the framework requires us to leave you with today. It leaves us all to just ponder the incredible theoretical future of quantum AI. Thanks so much for joining me on this explainer, and hey, keep questioning what's possible.